Every mechanical watch needs to be regulated in order to indicate time as precisely as possible. But the way mechanical watches are regulated has not changed much for decades. In fact, it hasn't really changed since the invention of the balance spring and the Swiss lever escapement, already centuries ago. Since a few years, watchmakers are working again on how to improve the regulating organ of watches. Developing new escapements or oscillators, which are the parts at the core of mechanical timekeeping, has now become a crowning glory for watch brands. Today, Frédérique Constant unveils an ultra-innovative concept with the Slimline monolithic manufacture and its groundbreaking oscillator.
Frédérique Constant is a progressive brand, always driven by innovations. Back in 2000, both Peter and Aletta decided to build their own manufacture caliber, what resulted in 2004 as the first in-house manufacture caliber. After this, we introduced a tourbillon, perpetual calendar, flyback chronograph, but also on the high-tech development we did the first Swiss-made smartwatch. Now we are going to introduce a world premiere. This world premiere is the 30 caliber from the brand, the Slimline monolithic manufacture. This caliber redefines the Swiss watchmaking. It's driven by a silicon oscillator that replaces 26 crucial components compared to a regular automatic movement. Thanks to its specific design and reduced size, the high-frequency oscillator is designed to fit into a regular mechanical movement. We have prepared a new conception for this, the 810 caliber.
Let's take a small step back and have a look at how a mechanical watch actually works. The basic principle of every mechanical watch has been the same since the 18th century. Energy is stored in a coiled spring called the mainspring. And after mainspring comes the gear train with gears and axles that drive the hands, and at the end of the gear are the escapement and the oscillator. The escapement comprises of the escape wheel and or lever, while the oscillator comprises the balance and the balance spring. And the escapement gives impulses to the balance wheel, while in return the escapement is regulated by the oscillator. And every oscillation allows the gear train to advance or escape in tiny little steps, so you can see the second hand moving with 5 to 10 tiny little steps per second. To understand the monolithic technology and how Frédérique Constant reimagined the oscillator, we have to go to Delft in the Netherlands to meet with Nima Toulou. Nima Toulou is founder of Flexus, an independent horology technology company that is specialized in flexible parts, or also called compliant mechanisms. Flexus has the knowledge of flexible materials, and they can design, develop and produce innovative parts for watches, like the monolithic oscillator that we will be looking at today. With its unique knowledge and expertise, Flexus is aiming at becoming what Bosch is for the car industry.
We all know the origami birds from our childhood, but what exactly is so interesting about them? Once I move the tail, the wings start to flap. It transfers force and motion from the tail to the wings, while it is made from one piece of paper. No assembly, no joints, in one part. It moves because it deflects. Flexible watch parts are essentially the same. They function because they deform. In contrast to rigid parts that rotate around axles and jewels, our technology transfers force and motion by bending of its own parts. We call them flexible or compliant mechanisms. Flexus technology can outperform classical solution by less is more principle. Our devices are monolithic, which means they are made out of one piece, and in most cases, one thin layer. They define a new benchmark for all performance criteria, such as for accuracy, precision, and runtime, in a most innovative way. The possible backlash and tolerance between parts are now non-existent, which is crucial to increase the precision. Because wear and friction are absent, the watch benefits from a longer runtime because there's much less energy loss in the system. And as there's no need for axles and jewels and a stone, they can become significantly thinner. Let's take a Swiss escapement. This is the heartbeat of a mechanical watch. It normally exists around 30 parts like a balance wheel and a hairspring that rotates around axles and jewels. Well, such a rigid part-based system inherently comes with limitation. Assembly of these parts introduce tolerances, which limit the precision and accuracy. The friction and wear between different parts create energy loss and reduce the runtime of a mechanical watch, and as well regularly require maintenance such as need for oil and cleaning.
This new oscillator combines three major innovations. The first one is the new geometry of flexures and masses. You can imagine we replaced those 26 components of conventional Swiss escapement with one oscillator. For example, the hairspring in a conventional escapement, this is like a spiral. And we replaced it by 4 straight flexures. And for the first time in history, in those flexures integrated, we created the anchor to have a geometry that is very optimal. Our oscillator is moving with only 6 degrees of amplitude, compared to the 300 degrees of a regular Swiss escapement. Together with this small amplitude, it also allows us to increase the speed of the frequency. And now we were going from a regular 4 Hz to 40 Hz, so 10 times faster. Instead of 28,800 beats an hour, we go to 288,000 beats an hour. And all this to increase the stability and the precision. Our second innovation is that our oscillator is ultra thin. It's actually 300 micron thin. And this is because we created everything in one layer of pure silicium. Instead of having one layer balance wheel, one layer hairspring, then of course the pivot in the middle, we don't have this. Only one layer, and it is pivoting on a flexible mechanism. This new topology is actually permitting us to decrease the size and having everything in a diameter of less than 10 millimeters. So actually smaller than a regular balance wheel. Together with the ultra thin thickness, this is really extremely compact. The third innovation is the regulation system. These actually are adjustable weights built on the oscillator, which allows us, just like a regular free-sprung balance, to adjust the moment of inertia and therefore the speed of the oscillator. With those special weights, the watchmaker can adjust our oscillator very, very precisely to a hundredth of a second instead of a tenth of a second in a conventional movement. Our oscillator is created from monocrystalline silicon. Silicon is 100% anti-magnetic, which is a great advantage in watchmaking. Because of this material and because of the fact that it's a very small and thin oscillator, we could actually reduce the weight by 4 times. The actual advantage of a low weight and low friction is that we don't need as much power as a conventional movement. And that means that we use less torque, less couple than in a usual movement. Less couple means less friction, means less wear. And this also results in the fact that we don't use any oil in this escapement. Because of this material, our oscillator is less sensitive to gravity and temperature changes. Very soon in the development process, it became clear that our conventional gear train could not cope with this incredible speed of this new oscillator. To make it turn 40 Hz, we had to redesign the whole kinetic chain. We actually had to recalculate the whole gear train ratio to make sure that the gear train could keep up with the incredible high speed of this new oscillator. We added a wheel to achieve this. Despite the high frequency of 40 Hz, we could achieve 80 hours of power reserve. And this is due to the very high efficiency of the movement. A regular mechanical movement is beating 28,800 vibrations an hour. That means that if you look at the second hand, it's moving 8 small steps per second. In our movement, the FC 810, the second hand is moving 80 steps per second. The steps of the second hand are so small that you cannot see it with the naked eye.
We can regulate the oscillator by moving the weights which are mounted on top of the oscillator. By moving them inwards, the oscillator will go faster, and by moving them outwards, the oscillator will go slower, just like the balance wheel, which we see in conventional movements. We can check the rate of the new FC 810 caliber with the conventional measuring device. We had to develop a new measuring device which works with the help of a laser. This laser can measure up to 250,000 beats per second. As a watchmaker, it is really exciting to work on this new regulating organ, which is the heart of watchmaking. It's a challenge to work on something new and unique like this. I couldn't think of something more difficult.
We are very proud of the Frédérique Constant team, but also the collaborations that made this happen. This is a milestone for the brand and certainly also a milestone for the industry. Frédérique Constant shows the innovations, but also the expertise and the passion behind the watchmaking.